So now let's look at our last set of operators before going into some other interesting stuff. We have the assignment operators here. We have a good number of them. You would notice that most of the assignment operators are simply a combination of the equal sign and some other operator that we have already come across. So let's see them, and then later on we'll go and look at one or two examples to see how they really work. The first one is the equals operator. Now you want to be careful. This is different. This is actually not equals. This is referred to as the assignment operator. It's different from the equals operator, that the relational operator, one that we use for comparison, which is two equal signs put together. This one is just one equal sign and it's used for assignment, and it actually assigns what is on the right to what is on the left. We have an example here. C is equal to A plus B, and what that does is it evaluates A plus B and it assigns the result in C. It's that simple. We are definitely familiar with this. We have been using it to assign values to our variables when we say x is equal to 4 or x is equal to 1 plus 2, and that's what it does. But be careful, don't use these in place of the comparison operator. It's going to put you into trouble. It's not going to compare. In a language like Java, you're going to have a problem. In other languages, it might just run and the expression will always evaluate to true. For example, if we're using it in an if statement. But with Java, it will not even let you make that mistake. It's going to complain. All right. Now, with that said, that's the only one that is not joined with another thing. The rest of them, as you see, are a combination of the assignment operator and some other operator, be it a logical operator or an arithmetic operator. And these are actually referred to as compound assignment operators. Sorry, not the logical operators. It's the bitwise operator and arithmetic operators put together with the assignment operator. I made a mistake and I said logical. That was a mistake. All right. So you'll see that these are a combination of one other operator, either an arithmetic operator or a bitwise operator, and they are called compound assignment operators. Why? Because they perform an operation and assignment in the same statement. This one, for example, the add and assignment operator, which is the plus and the equal sign put together. If you look at it here, you would see what it does. We say C plus equals A is equivalent to C equals C plus A. So what this operator does is it adds the value to the right, it adds the value it has on the right to what is on the left and assigns the result to the left. That's what we have. It adds right operand to the left operand and assigns the result to the left operand. So what this is going to do is it's going to add the value of A to the value of C, and then it's going to assign the result to C. It's exactly the same as doing this, and it holds the same for the minus operator, where we have the subtract and assignment operator. So you have the minus sign, then followed by an equal sign. There's no space between them, and what this does is it adds the right operand, in this case A. Sorry, it subtracts the right operand A from the left operand C and assigns the result to C. Same thing with the multiply and assignment operator. What it would do is, if we say C times equals A, what happens is it multiplies the value of C by A and assigns the result to C, which is the same as this. And it continues like that. The division operator, the modulus operator, we know that the modulus operator always returns a remainder. So when we do C mod equals A, what happens? It divides C by A. It divides the left operand by the right operand and then returns the remainder, which is stored in C. So the modulus of this expression will be stored in C. Same thing with the shift, the logical operators. This one, it takes in a value to an operand to the left and an operand to the right. In this case, we see C left shift equals 2. So what is going to happen is it's going to shift C by 2 places to the left, and then shift C by 2 bits to the left, and then it's going to assign the result in C. The same thing here, it's going to shift C by 2 bits to the right, and then assign the result in C. And with the bitwise AND assignment operator, what it's going to do is it's going to AND the value of C and 2, and then it's going to assign the result to C. So we're going to see all of that in action. Let's write some code and see how it really works. There's nothing big about it. We already know what assignment is, and we understand what these individual operators do. So these operators, the compound assignment operator, should not be a problem. So if I bring up my NetBeans, I'm going to go into my Java tutorial class, and I'll do the demonstration right inside here, inside my main method. So I could say int x is equal to 3, for example. Now, this is the assignment operator. If you print the value of x, system.out.println, I could say, ouch, the value of x is plus x. Sorry, lowercase. Java is a case sensitive language. And if I run this, you see the value of x is 3. Why? Because 3 has been assigned to this. You could also assign the value of a variable to another variable by using the assignment operator. I could say int y is equal to x. So if I come down here and I print this, I copy this and I paste it here, and I'll say the value of y is y, and I should have 3 for both cases. Why? Because the value of 3 is assigned to x and x is assigned to y. In this case, the value of x, which is 3, is copied to y as well, so they both have the same value, 3. This is assignment. Remember, I said do not make a mistake and use the comparison operator, which is the double equal sign that is used for doing comparisons, maybe in your if statements, or for doing expressions that will evaluate to either true or false. You don't want to mix the two. This is the assignment operator. The other one is referred to as the equals operator. All right. With that said, let's see what the compound assignment operators actually do. Now I have my x to be 3. I have x to be 3. So I could say x is equal to x plus 3. What am I doing? The value of x is 3. So I'm saying 3 plus 3. I expect x to now be 6. So the value of x is added to 3 is added to the value of x, and then the result is stored in x. So if I run this, I expect to see 6, and I have 6. Now this statement could be shortened by simply doing x is equal to x plus equals 3. Those two statements are exactly the same. If I run this, you see that, ouch, no, x was 6 from up here. This changed x to 6. So that's why we have 9. If I run this again, now you see x plus equals 3 is exactly the same as this. So what I'm doing in this first statement, I'm adding 3 to x and I'm storing the result in x. And here I'm adding 3 to the value of x, which is 6 from here, and I'm storing here. So if I run this, I should get 9. Now, I guess that is clear enough. Or let me run it again and you see the 9 very well. This expression added 3. This added 3 to x and stored the value in x. Now we run this again, we see that this adds 3 to the value of x, which was 6, and stores the value in x, and that's why we have 9. So if we take this out and we remain with our original value of x, which is 3, after running this, we'll see that x is 6. So you see that line 21 here, if I run this, you see that x is 6. So you see that line 21 is exactly the same as line 20, but it has just been shortened. And the same thing holds for all the other operators. Let's say x is 10, and let's divide 10 by 2. Let's say, okay, let's subtract 3 from 10. This should give us 7 because it's the same as x is equal to x minus 3. So you see, instead of writing x is equal to x minus 3, we go ahead and we shorten it this way, and that makes it all simple for us. The same thing goes with the division operator, and if we do this, let me make this so that no fractions are cut off, so that we remain with integers instead of having a fraction. So if I do this, this is saying x is equal to x divided by 2. So this will be the same as doing this 2. These two statements are exactly the same. So if we run this, we expect to have 5. 10 divided by 2 is 5, which is the same as this. If you take this off and you comment this out and you run it, you should expect the same result. And the modulus operator works the same. You could say x modulus 2. What happens is it takes the value of x, which is 10, it multiplies it by 2, and it stores the remainder in x, and the result of this expression should give us 0. And that's what we have there, which is the same as doing this. I hit insert. Okay, which is the same as doing this. And if we comment that out, you see that we still have a 0 because the modulus of 10 mod 2 is 0. And the same thing holds true for the bitwise shift operators. For the bitwise operators, x should remain there. I could say, let me comment this out and let's write the complete statement. I could say x is equal to x right shift 2. We know that when we are doing a right shift, we're dividing by 2. So this should give us 5. And if we run this, we have, sorry, when we are doing a shift, we are dividing by 2. Yeah, so we're shifting twice. So this should give us 5 for the first time. If we shift 1, we have 5. If we shift the second time, we have 2.5. But because shifts always truncates the fractional part, we end up with the 2. So let's first of all shift 1 time to get the 5, and then later on we shift again. So you see we have x left shift, x right shift 1. So we are shifting x by 1, and we have a 5. So you could decide and you shift that by 2, and we will not have 2.5, we will instead have 2 because it's truncated. And the same thing holds true for the left shift operator. In this case, we will multiply by 2 and then multiply by 2 again. So we expect this to give us 40. And that's it, which is the same as doing this. So we could come down here and we say left shift equals x, and we take this out, and this should still give us 40. X is 10, so when we shift it for the first time to the left, it gets multiplied by 2. We have 20, and we shift it again. So we are shifting the value of x 2 times, and we are storing the result in x, and we should have that print out our 40. And the same thing holds true for the zero field right shift operator. If we shift this, we expect it to give us our 2, like that. Okay, that's basically it for the compound assignment operators, and the assignment operator, which is the equal sign. But there's one thing I